Aaron, would you like to present work of Yuban?
Sure.
Please.
Didn't have a lot. I thought maybe another way to introduce the model is to specify looking at the interface of the cell, because I think it says like you look at the properties of the solar cell. I guess more specifically it would be like the interfacial regions at the active layer and the transport layers, which is, I think it's common to do one of them at one time, but doing both is a little more unique, so that might be something to highlight. And then you talk about applying the magnetic field. You say vertical, and by vertical I assume you mean like
Electric. Not magnetic.
what is, yeah, electric.
Yes.
Yes, electric field. So vertical is in like, if this is your layer, that way. So it's,
Orthogonal to the normal to the surface.
right. So there might be a more standard way of saying that. And then you note that there's a linear relationship between field and band gap, which is generally expected. But I thought maybe you could say something like due to something you see in the model, whether it's like the band gap of the perovskite closing, or whether it's like the levels of the transport layers moving. And then, yeah, those are my comments.
Fatima, do you want to add something to it?
Yeah, what's the reason of applying external electric field?
Is it the one that if you have more questions, you may show your comments?
I have 2 comments.
Please, I think we're fine with this time.
So my one comment is, what is the motivation of applying external magnetic field? What is the reason? That's the one. And the other one is what's the application of the output of this research? That's all.
Okay. Can you make a guess?
Yeah, it's written.
Like, what is your opinion? Why you think applying external electric field is beneficial?
For electron dynamics.
No, but for industry, like for why it could be useful.
For electronic device.
So what is photovoltaic cell in sense of electronics?
Like what's the mechanism?
No, like if you do electric circuits, you probably had a course in like radio electronics or electronics. Like there is a resistance, transistor, induction. So which element? How would you denote photovoltaic cell in a schematic diagram?
Transistor.
Which else? Just list 5 simplest elements. Induction, resistance, capacitor, transistor, and
Diode.
Yes,
Diode.
diode. So photovoltaic cell is a diode, and if you explore operation of diode, you apply different voltage, and scan the current. So it's a typical way to test how the device is working.
So the same thing in graphene?
Wait, we'll talk about graphene later. It's not for photovoltaics, it's for other things. But if it is a photovoltaic cell, applying voltage is the most natural thing what experimentalists are doing. Okay, yeah, thank you.
My comments are covered by them.
Okay. Most of them are cosmetic. If a non-specialist is reading, one may immediately define like roles of this components of sandwich, like light absorber, electron acceptor, electron donor. For general community, it could be. Then it's very good that this abstract points on the microstructure of interface. So it is what Aaron was doing as his first project, and what is important here, so that like specific groups may facilitate hybridization and speed up transfer. I don't know if there is a space to tell about it, but it goes this direction. One applies this, as Aaron corrected, normal to the surface electric field, but it is not clear here. Is it? I know what is being done, but from writing it doesn't follow. Is it ab initio modeling or perturbation theory by post-processing? And both are cool and interesting for the community. Here also it is a cosmetic. So first it is very logical. I like how it is written. So the first, there is an effect of electric field on the electronic structure. Point. Next, the perturbations to electronic structure lead to difference in dynamics. So like photoexcited dynamics of this interface is affected. It depends on the electric field because electronic structure is changed. This is a very good logical train of two steps. And I think it was also mentioned by Fatima, like which trends are found and what is the impact for industry. It's not critical, but just one can say nothing until like it is really important for improving performance or whatever. Okay. Would you be interested? Do you have comments about Fatima's work?
Yes, it seems to me some sentence read really odd. For this sentence, what's the meaning of this? Why the magnetic field is induced by the momentum dispersion?
Let me advocate. So I would read, if Fatima please correct me, I read this as a single word, like dynamics of charge carrier in induced by momentum dispersion. So it, the dynamics of charge carriers induced by momentum dispersion, and circle think is explanation in which materials under which conditions. So it's maybe just ordering, maybe swap the order.
And right here you talk about some electron hole dynamics, and then later you also mention non-radiative relaxation. So what's the meaning of electron hole dynamics here?
Probably right now it's not photoexcited lifetime.
So
Not current.
my understanding that Yvonne is not asking about the content, about the actual results in their description. To my understanding, Yvonne is demanding clear definitions without ambiguities. Because am I understanding you right? So there is the same
That
process.
sentence is odd, just the way it's worded.
So there is one effect, like dynamics of electrons and holes due to non-adiabatic, which is referred by two terms. And a smart reader will understand it, but someone under time pressure will have no time to connect these two things, and it's better to use the same term for the same concept. So just refine and rectify. You do I interpret correctly?
Yes.
Okay.
And here is another sentence which does not make sense to me. So what's the point of this sentence? What are you trying to say?
I will touch it when it will be my turn.
Okay.
It's non-trivial, and there is a problem that it's not cosmetic improvement of words. Yeah, thank you. Or do you want to add something? Do you have any comments?
Not a lot.
What?
Or not a lot.
Oh, okay.
So your first sentence, you say that layered materials have applications, but maybe just give a couple examples, because it's like people not in the material science field might not know exactly what a layered material is. I don't even know, is just graphene considered layered? Because like graphite is like layers of graphene.
Butter on the bread is a
Yeah.
layered material.
So it's semantics, but yeah. Maybe just be helpful to say like graphene, lithium disulfide, and
Mm-hmm.
those types of materials. Yeah, a couple of other things we've noted, just working on the grammar to make some sentences more clear. And then I guess there seems to be like two directions that you're kind of going at in your abstract. So on one hand, you want to compute like dynamics of Landau levels, or you mentioned that. So it's like if you start from an excited Landau state, how it dissipates energy. Then you also mention momentum resolved relaxation as well, and it's not clear how those two are like related to each other.
Mm-hmm.
So yeah, those are my comments.
Yeah, thank you. Dave?
You can go up there, mine with pure grammar comments as well.
But your grammar comments are critical. It is something that I cannot do for sure.
So the major one that wasn't already touched on was just you have some odd wordings. At least they seem odd to me.
So remove the word computation. Is calculated using method 1.
That would work.
One means it's a
The
reference.
one is the reference. I understand where the one comes from. But yeah, most of what I saw was just some sentences sound odd as they're getting read.
Okay. Yeah, thank you. Thank you, David. Same semantics as Aaron mentioned. Like, what are 2D materials? Like, as educated reader will know, but it doesn't hurt to give definitions. The reference to the growth direction here and there is it is borrowed from previous work on one-dimensional structures. Here it is very irrelevant, especially for graphene. Like, graphene is graphene. It doesn't have ambiguity. It is honeycombed. So applied magnetic field dispersion. So why it is needed? Why this part is needed from the engineering point of view? Like, why in the world when one needs to apply magnetic field to two-dimensional materials? What is expected? You already know the answer. You have some results, so you may just mention it, because telling that it is challenging, it is not sufficient motivation. Non-adiabatic calculations. Well, it's more technical, but the dynamics driven by thermal motion, it's important because it will compete with magnetic field. Also, it is not clear, do you target strong or weak magnetic field, because it may give different qualitative effects, and for like physicists and theoretical physicists it could be interesting. Landau levels, but how do we know that Landau levels exist in graphene? This concept of Landau level is designed for two-dimensional free space, and graphene has exotic momentum dispersion. So maybe there are states which are analogous to Landau levels, but not literally. Maybe if one applies very huge magnetic field, it will be, but then there will be interference between multiple electronics states. So I would be more careful, because it is possible to criticize by.
But if you apply magnetic field, there are Landau levels, because
If you apply magnetic,
quantum Hall effect. But for this research, I don't think we can say that. But there are Landau levels in graphene.
okay, but if you're confident and you do not want to spend space and time for arguing, just give reference.
Oh no, I mean, I think what I'm doing now, it's not relevant.
Okay.
So I can just...
But you don't need to answer right now. You address it to your best understanding. And there is a last but the major criticism. So you are referring to two methods, like the method 1 And David suggests to remove the word computational. Method 1 and wave packet based algorithm. So they are different methods. And it is not clear, like Redfield equation of motion for density matrix and evolution operator for wave function. So those are methods for two different objects, and it is generally interesting what is similar and different in them, and is it possible to combine them. So even if you do not complete the whole project but do some steps in combining these two methods, it will be big impact not for industry but for theoretical community. So if you just add recognition of the how complicated problem is and delineate what is you are trying to combine things that are hard to combine, it will be like appreciated. Okay, done with Fatima's work. Fatima, would you like to present work of David?
I don't want.
You didn't.
Yeah, I have.
Okay. And then David will go in a circle. Tell something about that.
Okay.
So I don't know what is its high absorption of visible light and
Long. You just missed.
I missed an L.
okay. And you need to describe briefly the method. What method you are going to use for this? And as usual, like applications of the output. That's all.
Okay. Yeah. Thank you. Good.
Because here you mentioned organic spacer molecules, but I guess the function of this organic spacer molecules is not clear. Will you just try to put them on the surface, or you just introduce them into the cages of the perovskite? And I guess you use two sentences to talk about stability of the functionalized perovskite. But in your study, are you actually did some calculations on the stability of the perovskite? If not, why spend too many words on this topic?
So it's most motivation.
Yes, maybe that's good for introduction, not for abstract. Okay, that's it.
Okay, thank you. Aaron, do you have any friendly criticism to David's work? Oh, yes, I see from here you basically written another abstract.
Yeah, not criticisms, just things to potentially focus on or to make the abstract about. So, just some possible photophysical properties that you could look at based on function of layer size. So, you could look at radiative or non-radiative rates as a function of how many layers you have, and or like the cooling rates that MATLAB spits out when you do the calculations. Then also like chemical composition for whatever you have at the interface, whether there's some sort of trend there. So just some ideas to kind of look on, and it's like you might not have an intuitive idea at the moment, but just when you're like compiling all the data, just check rates versus length size and see if you can see any trends.
Yeah, thank you. It's what you were talking in private. I don't know if all perovskite photovoltaics is dye sensitized. Like perovskite itself is like a dye.
Yeah.
One can and what Yuwun's project was perovskite between organic dye, which doesn't absorb, and titanium dioxide, which doesn't absorb. So it's like titanium dioxide sensitized by perovskite. I'm not insisting, but I would be careful with. Breakdown, you mean decomposition. Environmental stresses, primarily humidity. One method, you mean not theoretical method, but fabrication or synthetic method, right?
Yeah.
Organic spacer molecules between layers of perovskites. Organic and organic hybrid layer material, and we already talked about it in private, like what to put under this word blank, and Aaron already covered it better than I can do. So if your motivation is photovoltaics, you may have some desired properties like current, but because of the limited time and facilities, instead of computing current and charge transfer, there are some available properties that Aaron mentioned, like rates of relaxation and recombination, which are related but not they're not exactly what one needs for photovoltaics. And then just mention something about the method. Tell how happy you are with being novel, and make some trends, like how the properties, like structure to property relation, how the property depends on like chemical, what Aaron mentioned, composition and number of layers. And then tell that humankind will die without your discoveries. Okay. Would you like to present Aaron's book?
So basically, you mentioned positive and negative polarions, but you don't actually state what they are.
It's like in fairy tales. There are positive and negative characters, like good and bad. Okay, what else?
And then here talk about understanding polarion dynamics, but I was just wondering why we would want to understand polarion dynamics.
Mm-hmm.
From
Yeah, that was my-
the reading I give of it, the reason you would want to understand it is because they exist.
Yeah, and it's not
Which-
clear.
I suppose isn't the worst reason to want to understand it, but
Yeah, I added a sentence at the end, and their implications on recombination rates, because that's kind of one of the interesting things about polarions, anyway.
okay.
Yeah, thank you. Good to have.
I guess overall it looks very good, but I guess I have just minor comments. So for this sentence, I guess it seems there are two reasons, right? One is lattice distortion, the other is screening of optical photons.
Mm-hmm. I guess they're related.
Okay. Okay. And then here, so what do you mean by population and phase relaxation?
So population, like homo to lumo, and then phase is like the phase between homo and lumo, or it's like the off diagonal.
So there is
No.
space, you can explain it in a sentence.
I guess I have a question. So it looks like you are doing excited state adiabatic coupling calculations, right? So basically you are just like excite the molecule to a specific electronic configuration and just fix the electronic occupation and then do adiabatic coupling calculations. Okay. So how much difference it will make from standard?
It's expected that non-radiative lifetimes should increase due to like the lattice distortions.
Like, is there a number, like triple, double?
Well, I guess I don't know like the qualitative trends off the top of my head, but I know it's like the last Polaron paper I did, I compared the hot carrier cooling rates, and they were slower for the Polaron model, was just having one of the charges in the model. So I did see that trend.
Okay.
But then when you include both, it's like maybe the positive and negative cancel each other out
Mm-hmm.
because they're such a small volume.
Mm-hmm. Okay.
Yeah, thank you. No comments? Okay. So, I know from being collaborator of Aaron what is going on, but from the writing I do not see if these nanocrystals are protected, ligated, kept by ligands. And since it is substantial numerical effort, it like makes calculations 10 times more complicated for the same size. It's not bad to brag. Negative occupations, analogous photo excitation. So it sounds like this organization of numerical simulation is needed to prove that this encircled positive properties are exist. It is written between lines, but it is not evidently highlighted. So, like, why these calculations are done? Maybe to prove that beneficial properties exhibit there in the full strength in the system, or just make us logical steps. So next question is related to the question that you has posed. So there are rates of population transfer and dephasing, which dephasing is responsible for the coherence, and among experimental observables it is responsible for line width of transition. Like if there is optical excitation, the dephasing mechanism and its signatures in time domain are responsible for how narrow or broad is the line. It sounds from this explanation that parameters for population relaxation and dephasing are computed in the same way. It may need to be confirmed or opposed, just at certainty. I'm not sure that they computed in the same way, and there is an opinion that dephasing is based on energy fluctuations rather than overlaps of orbitals. It's not a big discovery, but to avoid ambiguities, one may just highlight it. Like population transitions are coming from non-adiabatic overlaps, and the dephasing comes from ergodicity, inhomogeneity, fluctuations of orbitals energy along trajectory. By now you know it better. And there are little triangles here and there. It is also, I want to echo the words of Yuval. It is what you were contriving while discussing your work. So it's really good that you refer to previous work of others, and you put you do not cite your own work, but it would be nothing wrong to put yourself in the same line with Redfield and Einstein. If I follow your works from the abstract, it is not clear what is new in this abstract, in the presentations that you're going to present based on this abstract. Will it be a repetition of previous works or something drastically new? In the sense of what you mentioned, the non-adiabatic couplings computed for different sets of non-adiabatic couplings for different excited states. In the community, there are some groups like Tammy Nelson, who is doing it on an everyday basis, but only for small molecules. For huge size quantum dots, it's kind of a breakthrough, and there will be nothing humble to brag about it. And then, even if the calculations are not yet done, if you have intention to use different sets of non-adiabatic couplings depending on how far you are on the trajectory of jumping between states, it is also like attractive thing that would impress the reader. Okay, I think we're done. So I suggest that reviewers return this written feedbacks to authors, and we further improve the abstracts, and the deadline, as you see here, deadline for registration and submission is December 31st. A little earlier is fine, but there is no rush. And also by this deadline, they have competition for Trevor Awards, which includes personal statement, research statement, and a letter of support. Why not to try? Okay. If there are no more if there are no more things to talk about, meeting is dismissed. Many thanks for investing your time in this activity, and I'm not sure if next week the room is available, but I'll send emails with updates. I'll stay here in the room for like 20 minutes more if anyone needs to talk one-to-one.